satellite transponder acts like a repeater. It consists of a receiver and a transmitter. The main function of a satellite transponder are to pick up the transmitted signal from the transmitter on the Earth, to amplify the signal, to translate the carrier frequency to another frequency, to retransmit the amplified signal to the receiver on the Earth. This is the block diagram for the satellite transponder. The BPF limits the total noise. The LNA amplifies the received signal and feeds it to the frequency converter. Frequency converter converts the high band uplink frequency to the low band downlink frequency. This is an RF to RF repeater. Each RF satellite channel requires a separate transponder.
Satellite system link consists of two links, which is uplink and downlink. Uplink is the pass of the satellite signal from the Earth transmitter to the receiver of the satellite. Downlink is the pass of the satellite signal from the satellite transmitter to the receiver on the Earth. So the green string represent the uplink and downlink.
Earth station is the transmitter, where the signal is sent to the satellite and the satellite will send the signal information to the receiver. This is the Earth station and the uplink to the satellite and then downlink to the receiver. This is Earth station transmitter block diagram. From the block diagram, the intermediate frequency modulator converts the input baseband signal to an FM, a PSK, or a QAM modulated intermediate frequency. The up converter converts the IF to an appropriate RF carrier frequency. The high power amplifier provides adequate input sensitivity and output power to propagate the signal to the satellite transponder. Now, this is an Earth station receiver. From the block diagram, LNA, which is a highly sensitive and low noise device, amplifies the received signal. The RF to IF down converter is a mixer and bandpass filter combination, which converts the received RF signal to an intermediate frequency IF. For the satellite system link process, the Earth station will uplink the signal to the satellite and then downlink the signal to the receiver. And then the receiver will uplink the signal and downlink to the Earth station. For example, if they have two satellites, so the Earth station 1 will uplink the signal to satellite 1 and crosslink to satellite 2, and then the signal will downlink to the Earth station 2, and then the Earth station 2 will uplink the signal to the satellite 2 and then crosslink to the satellite 1 and do the same process downlink to the Earth station 1. Satellite communication has a noise where there was a thick cloud. So to prevent this noise, we can use fiber optic or other alternative ways.
Application of satellite communication. Some of the applications of satellite communication are digital audio broadcasting, television broadcasting, service remote area, weather satellite, remote monitoring and control, vehicle tracking, mobile communication, maritime and air navigation, video teleconferencing, and lastly, defense communication. Comparison between satellite system and terrestrial microwave system. The advantage of the satellite system include it can access to wide geographical area, wide bandwidth, high reliability, and distance insensitive cost. The disadvantage of satellite system include high initial initial cost. It has propagation delay, regulatory license requirement, and limited orbital parking slot.